So there's a rectangular plot of farmland. One side is a river, though. That means we're not going to have to fence this side, I guess. Why? It's an electrical fence. So I don't know what's going on. I'm fencing in some animals. I guess the animals can't swim because here's my river. Okay, I have to fence these other sides though, and I've got 1,000 meters of wire at my disposal. So what's the largest area we can enclose? So let's write a function for the area. Okay, the area right now we'll keep it as a function of two variables because it depends on the length, and there's two of those. Oh wait, sorry. Yeah, there are two of those. The area of this thing is the length times the width. Because it's a rectangle, this side has to be the same as this side. So L times W. That's what we're trying to maximize. But we can't maximize it because the skills we have are only for one variable, right? We could take a derivative and set it equal to 0, and that finds us potential maxes and mins. But right now, there's two different letters, so we're kind of stuck. But we can use the fact that we have 1,000 meters at our disposal and the fact that it's a rectangle. So the entire perimeter, we're going to use all 1,000 meters. That equals the width plus 2 of the lengths, right? Because you got one of these plus 2 of these. That should make 1,000 meters because we're going to use every piece of fencing that we can. Now I can rearrange this equation. I can just subtract that 2L from both sides. And now I have something I can substitute in here. So the area, instead of length times width, I'm going to say it's length times what W is equal to. I just found that other equation. The W is 1,000 minus 2L. And now this is an equation I can maximize with some calculus. Okay, I can distribute that L. Actually, you could avoid calculus on this one. I'll show you in just a second. L times 2L makes 2L squared. And so if we're trying to maximize something, we take a derivative and we set it equal to 0. That helps us find our critical points, and we want to remember those are potential maxes and mins, they're not guaranteed. Okay, but take a derivative of the area and set it equal to 0. So the area, the derivative of the area with respect to the length is 1,000 minus 4L. Set it equal to 0. And then solve for L. And if you do that, you've got 1,000 divided by 4, that makes 250. L equals 250. And then you'd want to test that, but for these word problems, you're probably going to find that these are always going to be maxes or mins, whatever you're looking for. But if you test that, if you plug that in, if you try to plug in a number to the left and to the right, you'll see that 250 is a maximum for the area. Okay, so the length of the maximum area will be 250. The width, we can find that out real quick with this equation up here that we rewrote, right? You could plug it in either one, but this one's easier. 250 in for L, that makes 500 for W when you solve. So when the length is 250 and the width, the width is 500 because you plug in 250 in here, you get 500 for the width. That gives us a maximum area of, 125,000 square feet. That's our answer because they wanted all three of those things. Okay, now I said you could do this without calculus because look, when we rewrote our equation for the area, this is quadratic. And the only maximums or minimums of a quadratic happen at the vertex, right? This one would look like this. The vertex would be there. And a quick way of finding the vertex is negative b divided by 2a. So negative 1,000 divided by 2 times negative 2. That's a positive 1,000 divided by 4. So it's 250. So you don't necessarily need calculus for this one.